Awesome. Welcome, you guys. My name is Ingrid. I'm representing Stockholm AI, where I'm the vice chairman. This is our second ever live virtual event that we do. So we're super excited to have you here after more than a year of not having any events or any physical events at all. So this is super exciting to host Schibsted today to talk about deep learning in production. And that's the first of two deep learning in production events that we have. We have another next week. So kicking it off now. I'll just start by introducing Stockholm AI briefly. And just to remind you all to go into Slido and enter the code U694 and just answer 2 questions on who you are. And then you'll be able to ask questions to the speaker throughout the presentation. Slide. Okay. Yeah. So Stockholm AI started out as a meetup originally. Some people in Stockholm wanted to just start out a meetup around AI, basically. But the interest was quite big and it grew really quickly. So in 2017, they thought it made sense to kind of formalize it a bit and created a non-profit organization, basically. And our purpose is to act as a platform for exchanging knowledge between experts in different fields relating to AI. So it can be business and it can be research and it can be basically as a student or an academic or just working with, for example, deep learning in production. And we are dedicated to establishing Stockholm as a global player within the field of AI and ML, as well as being the main hub for the Stockholm AI ML community, so that you'll be able to find like-minded people within Stockholm AI. And basically how we do this is that we revolve around events or event series in different formats. We have meetups, which is basically this, which is a bit bigger. It's more of a presentation mode, although we have questions and panels as well. We also have sort of academic reading groups, and we have different types of workshops and hackathons, etc., which are smaller and more interactive. But basically ranging from technical to very, very technical. But recently we've started to do more sort of AI and business-ish events as well. But this is going to be fairly technical, right? Yeah. And we couldn't be doing this without our sponsors, who are currently Ericsson, Poltarian, and Polarmind. So a special thanks to them as well. But with that, we'll just jump into today's event, where we have Maria and Sofie from Schibsted who will present. And then we'll have a sort of Q&A panel at the end with even more representatives. Brief overview of the agenda. We're currently at the introduction and welcome, unless that's obvious. We'll then have almost an hour presentation with Maria and Sofie. And then we will have a small break around 7, and then we will have the Q&A. And for those of you who are here live, are welcome to stay for a mingle. You can do that in the chat as well. We can leave the room open, but I think it's going to be more interesting for the live ones. But with that, I'll just kick it off and welcome Maria and Sofie. That's great.
I will actually do a quick introduction first. No problem. Okay. Yeah. So thank you, Stockholm AI, for hosting us, and also AI Sweden. I don't want to take too much time away from Maria and Sofie, so I just wanted to introduce who Schibsted is for those of you that don't know, a little bit about what we do, and particularly what we do in this area of data science, machine learning, and AI. And if you have any questions, you can always get in touch with me. So Schibsted is a Nordic company, big Nordic company, headquartered in Oslo, but with a very big presence here in Sweden as well. And essentially, it's a company that's across news media and marketplaces, and some new digital ventures as well that are popping up. And we have this mission in Schibsted called empowering people in their daily lives. And if I sort of put this picture out, for those of you here in Stockholm and in Sweden, you probably have used Schibsted frequently, like Blocket, yes, buying and selling Pokemon cards and finding apartments to live in and things like that, or reading news in Aftonbladet and Svenska Dagbladet. So it's a lot of different companies. And in Schibsted, we have a data and tech organization, which is quite large. There's around 1,500 people working there. In Norway and in Sweden, in Finland, in Poland as well, in Denmark. And we consider data and tech to be very critical to improving our products and services that we deliver to our users. And we have a mission to become basically the biggest data empowered company in the Nordics. And we want to do it in a transparent way as well. So everything we do, we do it with a kind of responsible hat on. We have people in privacy and in AI responsibility that are always making sure that everything that we do is right. If we zoom into the data and tech, we have a group called Data Foundations, and that's basically where I work in, as well as Maria and Sofie, who will be presenting. And the Data Foundations is a centralized group where we basically have a data lake, and we manage the data in there. The data is coming from behavioral events, as well as contextual content-based things. And what we do is we basically build machine learning models and features and embeddings, which are then used in all kinds of downstream tasks across all the different Schibsted brands. And we have a wide spectrum of different models that we develop. So we have both supervised and unsupervised. We have classical ML, we have deep learning. This presentation will be about going from ML to deep learning. And it's all in production. So if we look at some uses in Schibsted, when it comes to machine learning and data science in general, we have, for example, starting from the newsrooms like Aftonbladet, just randomized trials, trying different features, trying different things related to the articles and to the user experience, and then looking if there's a statistical significance with those changes, if they bring in more users, more subscribers, more revenue, more clicks. We have product and price recommendations, like in Prisjakt, in Blocket, in Finn, in Norway. We also do user segmentation and behavioral insights. Contextual advertising, which is my baby, that's what I work with. We have like smaller use cases as well, like print prediction, forecasting how many newspapers we should print in the next quarter, so we can save money and paper and so on. And also little things like detecting inappropriate content, for example, in Blocket. We have image detection classification models there. So one example is like what I work with, and this is basically contextual advertising. So let's say we have an advertiser that's building bicycles, selling bicycles, and they have an ad campaign. What we do is we basically build topic models, and in this case we just use standard LDA, latent digital allocation, probabilistic models that have been around for 20 years now, and they work really well. So we basically take some words from an advertiser, treat those words as a document, we pass it through our topic models, and basically get the highest probability topics, and then get some highest probability keywords from those topics as well. And then we can add those to the ad campaign and map it to our actual articles. So this basically maximizes the impressions that you would get for that particular ad campaign. And this is just contextual, so it's not using any user data at all, like no cookies, for example. And it's very effective. Finally, we are always looking for talented people. So we're looking for currently a lot of data engineers, full stack developers as well. In my team, we're looking for a master thesis student as well. We have some candidates already, but if anyone is interested, they can apply, and you can contact my teammate Björn on that email address. Yes. So with that, I will hand it over to Maria and Sofie.
Thank you. We will try to take over the screen. That's possible. Okay, I think you can show the screen now.
Yeah, I think we can start.
Yes.
All right. Welcome, everyone. We are very grateful to be here today at Stockholm AI and meet all of you. Today, we will talk about the journey of deploying into production our first user modeling deep learning pipeline by using sparse tensors.
But first, we would like to introduce ourselves and the ML engineers in our Team Predict. Team Predict's mission is to create enriched user profiles to push the boundaries of data-driven innovation.
My name is Maria. I love applying machine learning and deep learning for solving complex problems in a scalable and sustainable way. My background is in applied informatics, and I did a master's in data science and knowledge management. I've started my career in a company in Barcelona, and I joined Schibsted as a machine learning engineer a bit more than 2 years ago.
And I am Sofie. I love learning cappuccinos and bringing out the best in my collaborators. My background is in statistical data analysis, and I started as a data scientist many years ago in several consultancy firms, covering a wide range of fields. Before joining Schibsted a year ago, I was involved in developing recommender systems for the travel industry. I have been privileged to work with such an amazing team and can't wait to tell you about what we have been up to. But first, we would like to introduce our other two ML engineers who are in the room. First up is Niels. Niels has a passion for applying cutting-edge techniques. He is not afraid of taking lead in uncharted waters, and he is a real data visualization guru. And then Egil is there as well. He's our sequence modeling expert. He even has like a special emoji invented to symbolize his love for sequence modeling. Now, I'll just show the QR code again and Slido, because you can just pop up any questions there while we are going through the presentation. So I will give you some seconds to take a picture.
All right.
Okay, so let's kick off. So we started this project with an idea of improving our products by the means of AI technologies. The existing classical machine learning approach was producing limited returns, and we've decided to switch to a deep learning approach. Throughout the whole project and the transition from classical machine learning to deep learning, we have made many changes and applied several new tools to enable us to effectively put the new and better model in production. This path was full of challenges and learnings, which we will share with you today. We will kick off by introducing our technical stack, continuing with diving into our deep learning pipeline, and finishing up with our dreams about what is next. So, what about our setup and technical stack? We have been running pipelines for many years, big data and Spark. And the pipeline we will be talking about had an XGBoost classifier at heart before, since this was performing the best compared to other Spark MLlib approaches we've tried. We've used Spark ML framework for experimenting with k-nearest neighbors, GBMs, random forest classifiers, and XGBoost, both for regression and classification tasks. And later on, after facing the task of improving the pipeline performance and not succeeding in doing so with the Spark ML framework, we've decided to switch to deep learning modeling using a TensorFlow framework, including the Keras API in the TF Keras package. The Keras layers are very useful when building your own model with custom layers. Some other nice TensorFlow functionalities that are employed in our data pipeline are TF datasets and TF tensors. Now, the main idea was to utilize TensorFlow functionalities for building an efficient pipeline and skipping the feature engineering as much as possible. Even in this new pipeline, part of the large pre- and post-processing are still performed in Spark using the Scala API.
The existing pipelines have a quite complex tech stack. Most of our data resides on S3 in Parquet format and is preprocessed using Spark and Scala. Data analysis is performed in Databricks. This is our favorite go-to tool when it comes to data exploration. Our modeling is done in Python using Keras and TensorFlow packages, and this part is where the most fun and interesting things happen. We then containerize the pipeline code using Docker and deploy pipelines to Kubernetes using Spinnaker. And these last tools are the ones that we're involved in configuring the least. We have a setup that allows us for fast and easy experimentation. We can develop on a local machine using a small anonymized sample dataset, and then run the experiment at scale with real-size data by deploying a job to our development cluster in Kubernetes. We iterate on the development process a few times till we get satisfactory results, and then merge our changes to master and trigger the deployment process. And here, our continuous integration tool, Travis, will automatically build and test our code, push artifacts to our artifact repository, and trigger Spinnaker pipelines. Our continuous delivery tool, Spinnaker, will deploy the pipeline to Kubernetes, which will further orchestrate the pipeline. When experiments are successful, they are consecutively promoted to our pre-production and production environments. And when we are unhappy with the result, we roll back to the latest optimal state.
So now we finished up our first part, the stack part, and we will continue with looking at our data and our pipeline. At Schibsted, we capture behavioral events from interfaces across all our brands. So here you can see an example of what event tracking looks like on Aftenbladet. Clicking on an article fires an event, for example, an article view, and this event will capture, for example, the device type, the content type, and information such as tags, categories, and the name of the article. From these raw events, we will deduct different signals that can be used as input to the pipeline, such as object, time, and agent, user agent features. We use declared information from Schibsted user accounts for predicting characteristics of non-logged in users. These can be traits associated with a user like interest, age, gender, and home location. In total, Schibsted has around 18 million active users per day, generating about 1.5 billion events, which translates in a substantial amount of data, 28 terabyte of data in memory per day.
In the first step of the pipeline, the labels and raw events are preprocessed into sequences of events per user. We preprocess and build a supervised dataset in Spark and Scala, and we use Python to build sequences of events per user. This user data is then ingested into the model for training in order to do categorical predictions. And this stage is fully written in Python. The predictions per user can then be used for segment creation. Spark and Scala are used here to transform raw predictions into the format that complies with our internal standards. Where possible, we use Spark and Scala for fast and concurrent data wrangling. When building machine learning models for event prediction, we learn from the past and generalize into the future. We only take into account the last 25 days of raw events to make predictions for today. For tomorrow, we will do the same, shifting the look back window with 1 day and so on. The daily retraining of the model helps us to account for the data drift, which is the change of the input data, and concept drift, which is a change in the relationship between the model input and output. In the past, we would aggregate the data per user for all dates and then feed it into a tree-based model. This made the feature engineering part of the pipeline much heavier. Apart from that, feature engineering early in the pipeline can lead to increased technical debt and less flexibility when it comes to experimentation. In the new setup, the idea is to move away from aggregating events over consecutive days. We consider the prediction problem as a sequence modeling problem. We take advantage of the sequential nature of the data while avoiding a heavy feature engineering pipeline.
So if we look, for example, at a very small sample of a user, we can see that the user has a sequence of events. And here, for example, we see a pandas data frame with 2 users, 0 and 1, the date of the event, the day since the user has been online in the last 25 days, the hour of browsing, and the category the user was viewing. The idea is to represent the user as a time series of his or her raw events. Now, to reduce memory usage and find a way of practically translating the indices of user time steps and features into the model, the data was pre-processed from a tabular format into sparse tensors. Now, sparse tensors have 3 components, indices, values, and a dense shape. The indices tensor will provide the information about the user and the time step, which are days in our model. The value tensor will have a feature value for a user for a specific time step. And the dense shape is self-explanatory. It's the dense shape of a sparse tensor. Now, in the first example, we transform the hour feature into a sparse tensor. The user 0 on day 0 triggered an event at 2 a.m. Then the user 0 on day 12 triggered an event at 3 a.m. and so on. Overall, the transformed data contained information for 2 hours, or 2 users, sorry, along a time span of 40 days for one feature, the hour feature. In the second example, we perform the same transformation into sparse tensors for the category feature. Sparse tensors made it feasible to fit large batches of users in memory when training, taking into account the days in the lookback and the amount of potential feature values. We have many users with uneventful sequences, which makes sparse tensors a natural fit. Now, in the next step, we're gonna add a feature index, and each of the sparse feature representations are stored in a dictionary. This will allow us to have different dropout rates and vocabularies per feature later down the line.
Before we dig deeper, let's have a quick overview of the model. We build embeddings for each of our input features, and once they are concatenated, we feed them into a dense layer. The output of the dense layer goes through a one-dimensional causal dilated convolutional layer. And this part is followed by another dense layer, which passes the information to the output layer. And now let's go through the different layers of the model, starting with the first layer, which is a string lookup layer. The main idea is to transform every user into a time series and then make a prediction for that user. We start by generating a lookup table per input, giving an index to every word. The text of the input can then be replaced by its index, transforming text into integers. To reduce the long tail of sparse features, the vocabularies are pruned. For features with high dimensionality, only those items that have more than 50 occurrences will be taken into account. We also have tried using language models such as fast text and sentence transformers for the free text features, but performance and processing time constraints kept us from finding a feasible solution for moving these experiments into production. Next, we have the embedding layer. So we now have for our object category an input of dimension 5, as there are 5 possible integers ranging from 0 to 5. These integers can be one-hot encoded. This is, for example, the one-hot encoding of the integer 2 for the object category. To reduce the dimensionality from 5 to 2, we can multiply this binary representation by a certain factor, which we call weights. And a similar dimension reduction can be done for the browser data. This way, we can transform the integer inputs into numerical vectors. Next, all the numerical vectors will be concatenated per user and per day.
Perfect. So before, well, what happens as well in this step is a regularization technique, namely feature dropout. The dropout layers are set randomly to 0, which with a defined frequency rate at each step during training time, which helps preventing overfitting. Now, per user and day, we will have an aggregated and concatenated feature vector. In total, we will consider 25 days. And this white block, for example, represents 1 day of data. At this time, in the model, the sequence of days will be padded and transformed into dense tensors, which will be fed into the dense layer. Next, we will look into how we combine the sequences of days over the lookback period. Now, to combine the subsequent days, we use a sequence model similar to the one used in Google's text-to-speech models. The sequence model will allow us to combine data from 16 subsequent days in a very efficient way. This receptive field of 16 days helps us deal with new users and with users that have a limited history, which is often the case for our non-logged in users. This approach also makes us less exposed to decreased cookie lifetime. Now, when training we optimize for the categorical cross entropy, the accumulated loss over every time step given the past history of 25 days. Now at inference, we only take into account the last non-zero prediction. Furthermore, we randomly drop time steps per users, which are days, to make our model even more robust for uneventful sequences. Another form of regularization is randomly dropping patches of time steps. In our current approach, this means dropping consecutive days of data in the input layer in order to simulate restarts as if we were dealing with a new user. So we drop patches of data with the same length as the receptive field to induce clean restarts. Then the output of this sequence model will be fed into another dense layer with an output for each of the categories, representing the categorical probabilities of the model predictions. Now, deep learning approaches can be considered as feature learning machines, where each layer, except the last one, is just learning to transform the data into space, where the last layer can make a linear prediction on the desired task. A significant consequence of this is that these approaches blur the difference between the features and the model. So, where are we now? By transitioning from a classical learning pipeline with Spark ML to a deep learning-based pipeline with Tensorflow, we obtained several positive outcomes. Apart from performance uplift, we managed to switch to a better tech stack, which enabled us to experiment faster.
The output of our pipeline can be used for user segmentation, which forms the base for lots of different applications. And here are a few examples. One of the applications is producing aggregated insights about the audience that saw a certain housing or car marketplace ad. And this will help us with validating a hypothesis about who is our audience. We can also use segments for improving user experience. If there is a local school play or a local sports competition, we can employ segments to make sure you don't miss this relevant information. And the user segments can also alleviate the cold start problem. And another application is product development or product improvement. Segments can be used to find the right user groups for testing a launch of a new product, or when it comes to recruiting interview subjects. Now, in the course of productionizing the deep learning model, we have encountered quite a few technical challenges, and several of them that are maybe worth mentioning here are scaling. The transformation of pre-processed data is scaled horizontally. The process is orchestrated now in such a way that many data partitions are transformed into tensors at the same time using multiple resources in Kubernetes. Another one of the challenges was memory optimization. We've performed quite some code profiling, optimization, and parallelization to make sure we utilize the memory in the optimal way. Also session management in AWS for continuous authentication with IAM roles. We now refresh sessions to make sure that our long-running jobs have all the necessary temporary credentials. And the last one is pipeline stability. We improve the stability and cost efficiency of the pipeline by optimizing the resource usage in Kubernetes. We use things like node affinity, tains, tolerations to make sure that only required work runs on GPU-powered nodes.
So that was the last slide of the pipe. So now we want to talk a little bit about our dreams. What is next for us? So one of our dreams is to make better use of our non-logged in users. The data actually of our non-logged in users, hereby moving towards self-supervised learning. A pre-trained network trained by predicting masked features enables us to reformulate the problem into a multitask problem. This pre-trained network could be used similarly to transfer learning approaches in language models. Now, this summer, we were privileged to have two brilliant data science interns in our midst, Per and Marcus, who helped us with the launching this research space.
Great. Another one of our dreams is to build awareness of the environmental effect of the AI work that we do. And we made a few attempts to estimate the carbon footprint of our deep learning pipeline. And on the plot here, you can see how a single run of our pipeline, the pre-processing, training, and prediction stages, compares to the training of the most popular deep learning models in terms of CO2 equivalent. We are now looking into ways to build and use our pipelines in a more sustainable and environmentally friendly way, such as less frequent training and switching to training in the regions with low carbon intensity. On the map here, the dark green regions would be the ones with lower carbon intensity, and by moving our training to such regions, we could potentially reduce the environmental effect.
So another project that we are running at the moment, it's work in progress, it's the transparency project, and it aims to visualize the drivers of our predictions. As a part of our strategy at Schibsted, there is ongoing work on creating a risk analysis framework for AI developments. This risk framework will help us AI specialists ensure that we consider the topics of fairness, accountability, sustainability, and transparency in our work. We would also like to automate the hyperparameter optimization process further and push the end-to-end learning in our pipelines to the next level by feeding in the raw events without doing any pre-processing at all.
All right. Now, before we wrap up the presentation and move to the next section, we want to give you a brief summary of what we've talked about and also share a couple of learnings. We started our presentation with showing you our tech stack upgrade, which enabled us to do rich experimentation. We then walked you through our data and how we employ sparse tensors to perform optimized transformations. We further introduced our model and how different regularization approaches are used to achieve a better training effect. And we also gave you a sneak peek into our future plans and dreams. And here are a few takeaways that we would like to leave you with. First, we learned the hard way how important it is to design a scaling plan from the very beginning in order to avoid surprises further down the line. Another learning is that practical real-life applications of very promising cutting-edge models are really hard to put into practice in a production environment due to time constraints. Also, lots of time goes into making the pipeline efficient at the expense of experimenting with ML, as there is a high pressure to ship things to production. While delivering this pipeline into production, we have put great effort into making our development cycle and environment user-friendly, taking into account a long-term machine learning vision and trying to continuously improve the working environment and processes of delivering machine learning projects is crucial for pushing innovation and also getting us launched for an amazing journey in the AI space. Voila.
We would like to thank everyone for listening to our presentation. Let's have a quick break and feel free to reach out to our colleagues in the room. Armin, they will be happy to chat with you.
Thank you.
Thank you.
Hello. I need to keep adjusting this thing all the time. There we go. How should we do it?
Yeah, let's start with the questions. Okay.
Yeah.
Hi everyone. That's the talk. So let's move on with the Q&A that you have. I can see here in Slido. We will be bringing two more people up on stage.
Mm-hmm. So those two there, Egil and Niels.
Egil and Niels from the team that you saw before.
Yes.
You can, maybe we can fit all in the same screen. Let's see.
If we can position ourselves somehow. Maybe it's best actually because you are like the center of attention. So maybe it's.
I'm not the center of
Egil,
attention.
can you...
All this virtual.
There we go.
It feels like a team meeting.
I feel like my grandma is better than this.
Yeah.
Okay, so let's start with one question about the carbon impact. So Tianzong asks, how did you measure the carbon impact?
A very good question. We used a package called Code Carbon. This was our lab day project, and we went through different tools, and I think we were the most happy with Code Carbon. Highly recommend it. It's quite, the functionality is quite easy. I think you wrap the training script into a carbon tracker, and what it does in the background, it detects the cloud provider information, the region and types of instance you use, and then it uses something like a lookup table to see the energy consumptions, and calculate the carbon footprint based on that.
And you can also get a rough estimate by looking at ABS cost overview, and using that to calculate the runtime and knowing a little bit about the hardware it's running on, can get a rough estimate.
I think it's developed by Joshua Bengio's group, actually. So it's one of the godfathers of deep learning is behind it. So yeah, use it.
Yeah.
It should be good.
It should be good. Yeah.
Yes, we recommend trying out the package. We were very happy. Very good question.
Great. So we have another one from Armin. Can you share how much better the deep learning model performed over your old XGBoost models?
Yes, we cannot disclose a lot of details, but we can say certainly something about it. I guess it's a bit different because we have like different controllers, for example, Norway, Sweden, and Finland. So it's not like uniform over those controllers. And also we provide like a confidence score. So end users can do thresholding themselves and make like a balance between like precisions and the number of users that they want. So they can actually impact the precision that way. But if we have to say like a number, we could share, for example, the relative precision improvement is like, yeah, around 10% overall, we could say.
Great. Then we got a question from Philip. So when you mentioned you didn't deploy the sentence transformer experiment because of performance, did you refer to computational complexity or model performance?
In both, in a way, maybe, but I would say computational complexity. We have some limitation on when we need to deliver the predictions, and it was taking too long to finish the training cycle. So we have some room for improvement in those experiments. But yeah, and the performance, we didn't gain that much improvement with the overall performance too.
All right. Good. Then there is one question about explainability. How did you address explainability with your deep learning models?
Yeah. So basically, we did like a first step, which is like looking at the global feature importance, and this is done by like we train the model with all the features, and then afterwards we put like one feature to 0, and then look how that impacts the model performance. And depending on how much it impacts the model performance, we see it as having greater importance. So that's one way. And now in the transparency project, we are looking at local feature importance, but this is still yeah, work in progress. It's not fully decided. We've been looking in into different approaches, but yeah, I can't.
Working on it.
Yeah.
Great. So, and how often do you retrain the model?
We retrain the model now every day. Yeah.
Yeah.
Okay, that's straightforward.
That was an easy question.
So there is one question about the Databricks feature store. Have you started using the feature stores, and do you have any thoughts on how you share features, code, general, and it would be great to hear how you collaborate.
That's a very good question.
Yeah, there are multiple questions there. The first part, the Databricks feature store, I don't think we've started using it. And to be honest, we've started using Databricks quite recently, and it's still, we could say, in a tryout. We are in a tryout period. So we haven't used it, but it sounds like something interesting. The next part, I don't know if you guys want to take it, how we share features, code, and how we collaborate.
Yeah, I can try. Like, I think one thing to say about all of our pipelines is basically it's push forward. Like, we have a bunch of stages that depend on each other. And they are always persistent. Like every stage is persistent at S3 and version. So like, every day for every country, for example, we'll have a persistent data set. And then you can collaborate by, like, you can run an experiment by, you know, using that stage and then doing some kind of change. And so you can see it as like, you can build like a tree of experiments based on data. That's basically how we collaborate, but we have not collaborated that much in notebooks maybe. And so far, we're sort of trying to figure that out.
Yeah, we haven't used that like having Google Colab, for example. We have tried like our coding tools like IntelliGrid or stuff. Plugin you can do coding the same code at the same time. Then we use GitHub a lot. So.
Yes.
With the feature stores as well, we've actually, I think Björn, he started looking at it. So like I mentioned in the intro, we are in this data foundation, it's a bigger organization. So one of the goals is that we share actually features from individual teams. So for my team, contextual, what we do, for example, we can have a document or article embeddings, which could be potentially used by Sofie, Maria, and Egor and Nils, for example, in their models. So we are actually looking into this now, but we haven't you know, gone much further than just kind of exploring how we can do it.
Okay. I guess we would like to hear more when you
when
you have explored it. Great. So how do you take into account seasonality? For example, Christmas or summer activity?
Yeah, does someone wants to answer that?
I mean, first we retrain it, so that is one of the nice things with retraining. Today we will use train on the past 25 days, and then we will make a batch of predictions, like a list of user IDs with their new predicted traits on them that will be used for user that visit tomorrow. So the sort of, it's solved that way. We could probably get a lot of value from using data from one year before, but we sort of value privacy and complexity and lack of complexity.
There is, I guess, implicit seasonality in people's behavior, right? So I guess it's implied in the 25 days that we use.
Good. Have you considered using Beam instead of Spark, which seems to be better integration with TensorFlow? Is there a reason not to use it?
I haven't heard from it, like maybe others have. So I'm not really in a position to answer.
Yes, I think you're the alternative to Spark.
I looked into it. I think I tried it a little bit. If I remember correctly, it was better for streaming data or streaming and batch data jointly, but I've done much but TensorFlow integration.
I guess the way we integrate TensorFlow and Spark, it's just via S3. Spark will persist events in Parquet format on disk. Then we pick them up via, like, what is it, Panda, Arrow, etc. So they don't really meet each other.
But this is a good question, maybe something to look into at some point.
Yeah.
Cool. And last one, are you using any features or processes from this project in your recommender systems?
Yeah, good question. Like directly features or processes? I don't think so.
No, but like all the predictions are like fed into segments, and these are like used in a lot of recommender systems. Yeah, across the brands. I don't know if any one of you want, like in Sweden, wants to answer.
I think it's not really our department, to be honest. We'll make the predictions and then
And send them downstream.
Yeah.
Exactly. I mean,
but-
I know like in Finn in Norway, they have their own things that they're doing with their recommender systems. But yeah, I don't think so. I don't know actually, to be honest. You just send it down and then use it, right? Get some value out of it. So.
Yeah.
Good. But I think those were all the questions. So I will have to thank you for your presentation. Thanks for answering the questions. It was really nice to have you all here today. A couple of things maybe for the audience, for the live audience and the online audience. We will be sharing a survey right now on Slido, just in 1 minute from now. I think it will be very good for us if you can answer. These events, this whole hybrid setup is something new and we're testing it out. So it would be very good to hear from you and get your feedback. Other than that, we have the second part of deep learning in production coming next week. So you can find that on Eventbrite and our website also. I think that is all. Thanks, everyone.
Thank you. Thank you for hosting. Thanks
Thank you very much.
Awesome. Bye.
Bye.